Alright, we're going to do something called connecting factors with x-intercepts. The graph y equals x plus 4 and y equals x minus 2 using a graph calculator, then sketch the graph. X plus 4 is going to cross right here at -4 when you graph it. And x minus 2 is going to cross right here at +2 when you graph it. Alright. The x-intercepts are going to be -4 and +2. Whatever would make these guys equal 0. Alright. If we graph this quadratic function, right, and the product of the two linear has been graphed, we're using a graphing calculator to do that. Well, what we're going to get is we're going to get a graph that crosses at the same 2 points. Those x-intercepts are going to be true. So these factors of the quadratic, right, give us our x-intercepts. So once again, our x-intercepts are -4 and 2. What do you notice about the x-intercepts of the parabola? They are the solutions to the factors. Alright, if I set solutions equal to 0, right, those are the solutions. Alright, so use a graphing calculator to determine whether this is the product of these two right here. And what you get is this guy right here, right? 2x minus 3 crosses at, what is that, 1/2 right here. It's going to look something like this. And 2x plus 4 is going to cross somewhere like this. And if you graph this guy, sure enough, it's going to do this. It's going to cross at both spots. Alright. So, yes, right, they're the same intercepts. Make a connection about the linear factors and the x-intercepts of the quadratic functions. Alright, well, the solutions to the linear factors, right, where they equal 0 are the zeros of the parabola. Alright, let's keep going. Alright, so a quadratic function is in factored form when it is written as y equals some sort of coefficient and then 2 factors. So this is a situation, right? So multiply the 2 linear factors together. So multiply x minus 5 and x minus 2, which gives us x squared minus 7x plus 10, and then multiply the rest by 3. We've done something very similar to this. 3x squared minus 21x plus 30, and that's standard form, right? Once you multiply everything together, just like when we were doing it with vertex form. Alright, for this function, when k is greater than 0 and a doesn't equal 0, consider those questions. In standard form, for the standard form of the function, will the coefficient x term be positive or negative if a and b are both positive, right? So I'll give you an example. What if a is x minus 3, right? If I plug in, that would make a equal 3. So, yes, will be positive, because if I say x minus 3 equals 0, x equals 3, all right? So anytime I plug in a positive a or b, my answer will be positive. All right. In standard form, will the constant term be positive or negative if a and b have the same sign? Positive. Right? 2 negatives equal a positive, and 2 positives equal a positive. I realize that's totally shorthand. Alright. Now, for these guys, all we got to do is FOIL, something you've done a lot of. So, y equals x squared minus 7x minus x plus 7, or y equals x squared minus 8x plus 7. I'm going to go fast because you just took a test on this, and I really don't think you're going to have a hard time. If we FOIL these guys, we're going to go x squared. I'm going to just combine the middle term. We'll go slowly. Plus 3x minus x minus 3. Combine like terms, x squared plus 2x minus 3. Distribute the 4. 4x squared plus 8x minus 12, and that is our y. Alright. So, we got a little bit more to go, but I'm going to pause there. Alright.